In this lecture, we'll show you how you can draw a design diagram. So the notation we want to introduce to you is called the business object notation. But ideas presented in this lecture are also transferable to other notations such as UML. The unique feature that we're going to talk about for bond is about the inclusion of contracts into your design diagram. That's something we'll see. Let's first of all see the learning objectives for this lecture. Number one, we want to really understand what the purpose is for the design diagram. It's really about to create an abstraction of your design. So we will talk about what abstraction really means. It's really about being selective. Number two, we want to learn about two common architectural relations, client-supplier versus inheritance. And number three, we want to know how you can present a class. Either you can show it in a compact view or you can show it in the detailed view. You have to know the notation. Number four, we have to denote a class or feature as deferred or effective. Deferred simply means abstract, and effective simply means is fully implemented. And let's first start with why a design diagram. So what's really the purpose of this using a design diagram as opposed to just your source code? So you should really understand, first of all, source code is not really an appropriate form for communication. It's too detailed and also too language specific. Using a design diagram, it really shows being like a selective set of important items, such as, so you want to show clusters. So these are like packages in your Java programming context. And also you can show classes. And now for each class, you have to say, you have to show in your diagram, if necessary, whether it's deferred, abstract, or it's fully implemented. Also, should it be generic with a generic parameter, which we talked about previously, or should it be non-generic? Okay, so I would say typically for collection class, it has to be generic. For non-collection class, you will be you'll be without a generic parameter. Or if you also want to show architectural relations, for example, client-supplier versus inheritance. That's something we'll talk in details later in this lecture. And you also may want to show routines, either queries or commands. Again, for queries or commands, you want to say whether this particular routine is either not implemented just yet at this point, which means the implementation is deferred until subclasses. And also maybe it's fully implemented, or it should be redefined. For example, maybe at this level I'm doing a linear search, but later on I'm going to redefine that to be a binary search for efficiency improvement. Okay, so these are all the terminology you should really get used to by the end of this lecture. Okay, and also most importantly, you have to include contracts, because contract will be specified in the mathematical form using predicates. So anyone even without the understanding of any language syntax, they will be able to understand the obligation and benefits of the clients and supplier. So we had to specify precondition, postcondition, and class invariants. You don't necessarily have to include all the contracts in your source code. You just include those you think that are necessary for communication with your clients. Okay, and your design diagram is really called an abstraction of your system because you're being very selective about what to show, filtering out all the irrelevant details. So the clients do not necessarily have to know every single detail of your source code. You only show, for example, if you want to present the iterated pattern, in that case, you only have to show the relevant classes involving in the iterated pattern. For other classes not really involved, you don't have to show in the diagram. So for you as a designer, you have complete freedom about what classes to show. At the same time, you have the responsibility to include everything that's necessary for the comprehension of your clients about your design, right? Okay, number two, when you present contractual specification of your class, for example, if you want to include class invariant that involve a cross loop, you shouldn't really put a cross loop. For example, across all should be converted into universal quantification. That's just one example. And also, if you have a cross sum, you should also convert that into existential quantification. So in the bond diagram that you show, the design diagram in general, you shouldn't show any programming syntax whenever possible. Okay, you should really show mathematics whenever possible. Okay, that's about the general motivation and idea about why we should really draw a design diagram in addition to your source code. And later, for the rest of the lecture, we're going to introduce to you the various notations for the bond notation. So let's now see the very first feature for the bound notation. So when you present a class, you really want to determine whether you want to present it in a detailed view or compact view. So what's the difference? Let's go over some principle. So the detailed view really shows a selection of features and contracts. So features can be queries or commands and also attributes over here. So features here really meant routines. And also you can show attributes. And for the contracts, you can show precondition, postcondition, and class invariants. So those are things that potentially you can show in your detailed view. And also, you want to use a detail view. If the reader of your design diagram, they should know such details of a class. If you don't think they should really know such details, you should present in a compact view. So for example, class is critical in your design or implementation. You should really show them. For example, in your introductory tutorial, you talk about birthday and also birthday book. So these two classes may have to be shown in the detail view. On the other hand, what classes should you show in the compact view? So you should really show compact view if the reader shouldn't be too bothered by such detail, either because they are not important, that's they are just implementation detail, or number two, they are more like a common sense. So I would say minor helper classes, usually when you have helper classes, it's very specific to your implementation, unless you believe your reader should really know about it. Otherwise, you wouldn't show the helper classes in detail. And also, library classes, for example, array, linked list, or hash table, they are very standard notion of the data structure. So you don't really have to show what's really available in the array class in the detail view. You can show them simply in the compact view. Okay, so that's about the principle here. Let's see some the visual notation for the bound diagram. Okay, so here I'm showing to you basically two classes. I'm just naming them foo, the same class. So now, depending on your judgment, either you can show this particular class called foo in the detail view, in which case you have to include information such as you want to include different feature sections. Okay, of course you don't have to show all the features, just the relevant ones. And for every feature, you should really include the export status. So we talked about already, export status simply means what other client classes can actually get access to these feature section. For example, if you say none, it's a very special case to say private. So whenever you say a particular feature section is private or exported to none, so that means they are simply just implementation detail. But if you believe your reader should know such stuff, for example, if you want to show that under the hood, you're really using an array or hash table to implement, if you believe they should know, you should show them. And then also you should really include contracts. That's really important. So here I'm only showing to you the invariants, but maybe for individual routine, you may also have to show precondition and postcondition. You will see more examples later. And there's invariants, so you can see just using mathematical notation here. So rather than less than or equal to, for example, you should show less than or equal to, right? Rather than across all, you should really show universal quantification and etc. You should really use mathematical notation whenever possible. And also should also show some informative tag. On the other hand, if you judge that this particular class called foo is not so important or simply common sense within the context of your clients, in that case, maybe you can simply just show the compact view, in which case just show an oval shape over here. Okay, so that's a difference, whether to show the detail view or the compact view. Unless you're given explicit instructions, you can make your own decision, but it has to be justified properly. Okay, so let's now go back to the slides. So these two views have been shown already. So now you have to think about, for your particular application, should you show each class in detail view or compact view? It might be just a mix of these two views. The next item will be how you can show contracts in your design diagram. You have to really have a mathematical mind when you actually want to show in the design diagram. So let's talk about the principle. So when presenting the detailed view of a class, you should include contracts of features which you judge as important, while class invariant and also for the precondition and postcondition for your routine. Let's say this is one example there. I'm going to go over with some detail with you. You should really study the details yourself. And then principle will be you should really include the tag for each contracts. So, and the tag name should be informative. So the clients, even though they don't really get exactly the mathematical meaning, they can still see from the informative tag. And also you want to use mathematical symbols whenever possible, right? You should really use for all they exist, and also less than equal to set membership or function subset, etc. Okay, so let's now switch to iPad, and then let's see how we can just give you some idea about for this particular example detail view. you first of all show the name of the class, and then you should really indicate whether it is fully implemented or not. So plus over here simply means effective, and we'll talk about other possibility a little bit later about being deferred. Okay, we'll get there. And then we got different feature sections over here, right? You can see for every one of them, you can see for this particular one, it's not exported to, it's not restricted to any client classes. So it's as if it's simply just public. Okay, so this one here is also public. On the other hand, you can see this feature section is exported to none, so that should be like a private. There might be somewhere in between, so you might want to say this feature section should only be exported to class A. So it will be up to your design decision. So we got queries, we got comments. If you don't show any contracts, you should at least show the comments over here, right? But typically, you should really show some contracts. And then for every routine, like a query or command, you should also indicate whether that particular query or command should it be effective, fully implemented, or should it be deferred, which means abstract. So you should really tell between over here either plus or star. So plus over here means effective, which we'll talk about, and also star over here will mean deferred, abstract. Okay, and then you can see now for this particular command over here, which is effective, you can see the plus here. You show parameters, and then you show some comments, and now we got only the contract view. Typically, you don't really show any do block, the implementation. You only show the contract view. So require the precondition and also the post condition here. You can see I'm using less than or equal to the mathematical symbol. And then here, you may have to use the O keyword if necessary. And then I would say for the twin or deep twin, you can try to keep them if you wish, but it's not so critical. But you can feel free just to use twin or deep twin when necessary. And then I'm using tilde for object equality. And then you can see I'm using the for all quantifier. I don't really use across all. So you want to be careful. You want to stick to this convention here. You want to make your design diagram as widely comprehensible as possible, especially by those people who don't know about IFO or don't know about Java, right? Maybe they only know about mathematics. That's something the least assumption you can make. Okay, and then so this is another private feature here. You can see this implementation. We're indicating that particular implementation is simply effective. It's being implemented. Okay, and then we also got class invariants, and then with the informative tag, and then just some Boolean expression here. You can see for the detailed view, there's so much information that's contained over here. So you don't want to, on the one hand, you don't want to oversimplify by excluding certain information that's really necessary for the understanding. On the other hand, you don't really want to be overwhelming. You don't want to put all the details over here to really overwhelm your clients who's going to read your design diagram. You have to strike a balance over here. So I'm only telling you the principle over here, exactly how you do it. You have to judge with your particular application. Okay, so now let's move back to the slides and let's move on to the next item. So we have already covered about how you can include contracts in your detail view. Let's talk about generic versus non-generic classes. So we talked about how you can use and write generic classes previously. So let's see how you can present the design view to your clients. So a class will be generic if it declares at least one type parameters. It could be 1, could be 2, could be 3, but at least 1. So collection classes are in general generic. Array, hash table, you can see for hash table, you actually got 2 generic parameters. And G will be the generic type for value, and H will be a generic type for key. Okay? The order does matter. Okay, so type parameters may or may not be instantiated over here. So you can see, let me just show you on the iPad so how you can understand these 3 examples over here. Okay, you can think about over here, when we talk about hash table, so this is basically what's in the library, in the base. Okay, as I said before, G over here is the value type, and H over here is a key type over here. So now, G and H are simply just generic parameter. That's one way to include it. They are not instantiated, but you can also present the case where you got some application class which inherits from the generic class, in which case the generic parameters will be instantiated. So now let's say my table number 1. So if you present such class over here, that means you have the corresponding source code as follows. So that means over here I have class and my table 1. And then I would say it inherits from the library class. It doesn't have to be a library class. So if you want to inherit, you can inherit from any other generic class, even those that you created on your own. Inherits hash table. And then we'll say over here, so now I'm going to instantiate a G by string. I'll just say S over here, so you'll understand what I mean. And also H by integer. I'll say I over here, right? So that will be the rest of the source code. But now to really present inherits and also this particular generic instantiation, first of all, for the generic instantiation, you will create, you will present in this way: my table 1, and then string and integer. So that means we're really instantiating some generic class. On the other hand, if you want to show the inherits relation, which we will show a little bit later in the lecture, but I'll just give you some preview. So what you will do is, if color is allowed, you'll simply draw a red arrow vertically and single line arrow. And then over here, I'm going to include the parent class over here. Let's say I also want to show the compact view, right? Here, again, I'm showing compact view for both, but you have to judge whether you want to show any one of them in the detail view. So this will be the hash table class. So I would say hash table over here, and that one there has the G and H being generic. Okay, so now it's a recap. So now we got two classes over here. This is a child class, this is the parent class, because they are connected by some inheritance arrow over here. And then for the for the parent class, we got two generic parameters, G and H. For the child class, we instantiate both G to be string and also H to be integer. Okay, that's how we present it. And you can also show your generic classes in a detailed form if you wish. Again, whether to show in compact or detailed form, you have to judge whether you want to include those details. Okay, a very similar example here. Let's say this is the parent class, let's say, and the database of G is only one generic parameter. And then you may have two subclasses, for example. Let's say the first subclass is going to instantiate your G over here by string, and the second one instantiate G by person. And then if you want to also show inheritance relation, I'll show you quickly. Again, you will draw the inheritance arrow over here, and then you might actually have, in this case, two subclasses, right? So you got two arrow over here, and then you're going to show my db1, for example. I'll just say compact view. So that'll be my db1, and that one effective, so I would say plus over here, and also my db2. So that one is also effective over here. Okay, and then of course you also have to put the string and also person to show that you really instantiate the G to be an individual type. And to running out of space, but when you use the tool to draw it, you can definitely accommodate space. So over here, that would be a string, and over here, that would be a person. Okay, of course, you're gonna spell it out, the class name fully. Okay, that's about how you can present generic classes and also their instantiated classes. So just be careful about whether to show the compact view or detail view. Let's now move back to the slides. So we have talked about compact view versus detail view. And now what about non-generic classes? Basically any class without any generic parameter, or any class that doesn't have to instantiate any generic parameters from their parent class, they will be non-generic classes. Okay. The next item will be deferred versus effective. So as I said before, deferred simply means it's unimplemented or partially implemented, approximately equal to abstract in Java. Okay, but for the rest of the course, I'm going to say deferred. And effective simply means it's fully implemented. It's like a concrete as opposed to abstract. So what about classes? So we can talk about deferred versus effective at the class level or at the feature or routine level. At the class level, when you say a class is deferred, that means at least one routine or feature is unimplemented. So you can think about it's really whenever there's a deferred class, so that means you cannot instantiate a particular class at the runtime. So as you learned in the previous OOP course, so when the deferred class is there, you can only use it for declaring the type of some variable. On the other hand, you cannot really use it as a dynamic type to instantiate. That's something that's some basic from the OOP course. Okay, that's beyond the scope of this particular lecture. Okay, and then let's say, for example, you can declare the list class, which is deferred. It's a deferred class from the IFO base library. You can look it up. You will see deferred class in the declaration. And then you can only use it to actually say list being a static type. However, you cannot say this. When you say create list.make right away, remember implicitly we are saying the curly brackets list over here. So you cannot use list as the dynamic type. That's illegal, right? You cannot do that either in Java. On the that's exactly the equivalent over here. So that's not allowed. Okay. On the other hand, an effective class has all the features implemented. That means everything is effective. That's why the name. And then it may be used as a static or dynamic type. But remember the principle we talked about previously. Program from the interface, but not from the implementation. So you can say I use some deferred class as the interface type or as a static type. On the other hand, I can say now I can use any descendants effective classes as the dynamic type over here, right? I'm saying linked list over here is a descendant class of the static type list. So this is allowed. If you're wondering about why such polymorphic assignment will work, you can either refer back to your OOP course previously, or we're going to see some review later in this course, okay? And then you can also use array list, which is just another effective descendant class of the list class over here. Also remember in iPhone Studio, you can also look up the descendants versus ancestor for a particular class. Okay, so now let's talk about defer versus effective, and also we got another term called redefine. So we talk about these three things at the level of features, particularly routines, because routines usually have implementation. So we have to talk about whether the implementation is fully supplied or is partially supplied. Okay. So now let's say defer feature or routine is deferred with its header only. So you only got the name, the parameter list, if any, and also return type. Return type for the queries, but for command you don't have return type. Okay, so the word defer really means you want the descendant class later to actually implement this particular feature. But if the current class has this particular feature being deferred, that means at this current class we don't want to supply any implementation. We defer that implementation to later descendant classes. Okay, so and then this is one example here. Let me show you the example on the iPad. Okay, over here. So now we got three classes over here. Okay, let's see how the classes have been set up. So the top super class over here, we got deferred class. So you can see defer over here. Okay, so that means this class can only be used as a static type. It's only partially implemented. More precisely, you can see over here, this is the feature that's actually deferred. And that's programmatically how you do it. You just say deferred end. Okay. And then search is simply just going to tell you whether a particular element is actually there. And by the way, this class over here is generic. Okay. And then let's consider another class at the subclass level. So let's say database version number 1. So this one here is also G. But now notice that the G here is more like an instantiation of the G over here. They just happen to be of the same name. And then you will inherit from database over here, so there should be a slight typo here. This should be also the G over here. Okay, so now we are using this particular G for instantiating the G from the parent class. We just choose the same name, just for convenience. And then we have search over here. So now you can see do end. So that means this particular feature here is effective. Okay, so now that means at the parent class, we defer the implementation for this particular search, but now we are making that effective at this level over here. So now let's say we only just do a linear search, which is like a linear time algorithm. And now let's say for another subclass over here, let's say we simply got, let's say database version number 2. And now it's also generic, and we are we inheriting from this particular class in a similar way. So you can think about over here, this is the generic parameter, and that was used to instantiate the G from the parent class. Okay, and then we had to say now we want to redefine the linear search that's contained in the parent class. And now, so for this search here, we'll still say do an end, but now we can just redefine whatever implementation that's there. You can think about redefine as like override in Java. Okay, but I'm going to use redefine. So that one there is going to do a binary search instead. So now how can you actually understand this? So basically what we are having is like this. So we have database, and that one's generic, and also it's deferred. So I'll put a star over here. And then, so this is the top class. Let me just show compact view over here. And then we have some inheritance relationship over here. And then we have database, I'll just say DB for short. Database version 1. And that one there is also generic. And then I'm going to put also in the compact view. But this one here is effective. You can see there's no defer anymore, right? And then that one there is going to, I'll put a feature in just a moment. And then we got another subclass over here. And that one there is database version 2. So I would say database version 2. That one is also effective, also generic, also G. Okay, so that's the third class. So now what about the feature here? So you can see we got search, and also search at all the 3 levels. How can we denote that? Okay, so now let me just sketch informally, but you're going to see the formal, if you really want to include this particular search, you have to show in the detail view. Okay, but now let me just sketch informally for you. So you're going to say search. Of course, you might put the, you want to put the parameter as well, right? G and also G, and then Boolean. So now for this particular search, it is actually deferred, right? So you will just go after the header, you will simply put a star over here. Okay, so that's deferred. And then at this level over here is effective, so it's a linear search. For simplicity, I'm just going to put search over here, but I should really spell it out, the whole header. But now it's going to be effective, so I put a plus here. And then for the next class, it's actually redefined. So I would say search again, you got to spell it out, the whole the entire header. And now you'll be plus plus. So the difference is, you can see over here, the star means deferred. A single plus means effective. It's inheriting something that's deferred and just making that effective. And then the plus plus over here means redefined. I'm just previewing some stuff which I'm going to talk about later in the lecture, but I think it's a good timing to talk about these 3 classes. But again, when you draw the design diagram, you shouldn't just put these features outside the oval shape. That's not what you should do. I'm just doing some informal sketch for you. But later on, when you want to include such features, for example, in all the 3 classes, you should really show each one of them in the detail view, so you can properly put the search under some feature section. Okay, so now let's go back to the slides. So we already talked about, for this particular inheritance hierarchy with the database version 1 and database version 2. So I'm going to let you read the slides. So we already illustrated the relationship very thoroughly. Okay, so that's about linear search, and that's about the redefined feature for binary search. Okay, let's just talk a little bit more about classes which can be either deferred or effective. How can you denote that? Okay, so the way to denote the deferred class, as I showed to you already, is to put a star. And then for effective class, it will be a plus. And later on, we'll see for deferred and effective, we apply the same notation for each individual routine, like a feature. And then you don't have any redefined class. You only have a redefined feature. So for redefined feature, you will say plus plus. Okay. Okay, so now this one is pretty straightforward, but let me just denote to you very quickly, right? So over here, you can see for example, for this particular generic class list, it is deferred, which means at least one feature there is not implemented. It's partially implemented only. On the other hand, for linked list class over here, again, it's generic, but it's effective, which means every class, every feature that's in the linked list class is fully implemented. Okay, so you can see other cases as well. Okay, let's go on to the next slides. And now what about, so we got, yeah, again, you put star, you put plus, and also plus plus. So plus plus is actually for redefined feature. Let's see example. So this actually corresponds to what I just said about these 3 classes. Okay, over here. So again, if you want to show the a feature being deferred, effective, or redefined, you shouldn't really follow the informal sketch that I drew to you. But if you want to communicate ideas informally, not for submission, that's okay. But for the formal diagram, you have to draw like this. I'll highlight it to you. So number 1, we got a database class deferred. We got a database version 1 effective. Database number 2, version 2, also effective, right? And remember the inheritance relation we got before over here. Okay, I'm not going to repeat it. And now let's talk about just the feature that we spoke about before. But it seems like I didn't include a search routine in this particular detail view, but that's okay. I think I got another example for you. Okay, let's take a look. So you can see add item. Okay, you can see at a database level, this particular add item is simply just deferred. Now the add item in the subclass over here, it is effective. You can see the comments here. Simply append a new item to the end of the array. And also you got add item at the further subclass. It's actually plus plus, which means it's redefined. And now that one there to say simply insert a new item in the right slot so that the array is sorted. More like an insertion sort idea. So that's similar to the search. So now you got deferred, you got effective, you also got redefined. Okay, let me highlight some other things you may want to see. Of course, later on when you show this particular relationship, you might actually put some inheritance over here to be a class, maybe the detail view, also inheritance, also another detail view, right? So I just don't have space over here, but you can see the idea. Let's highlight some important information here just to remind you. Okay, again, export status, maybe for example, in this case, private. And then you got to show the contract view with informative tag and also use mathematical symbol, for example, negation rather than not, right? You want to avoid that. You want to avoid syntax from the programming language you're using. So just use mathematics. And then also we got post condition here. We got also a post condition here. You can see we're using existential quantification rather than across sum. And I think over here everything's being set. And for feature, for example, this is the effective feature, right? You want to denote almost every feature if possible. Okay, and again, this exists over here. That's actually redefined, corresponding to the exists that's actually effective. And also the exists over here, that's also defer. I think it's a very common pattern because for inheritance, that's for you to gradually either to supply implementation in the child class or to really redefine implementation in the child class. It's a very common usage of inheritance. Okay, finally, you can also take this as a case study for what does it really mean when the items are simply just sorted, right? You just put it in the mathematical form.